C.2, average efficiency. From this title, you can see we just use the average efficiency to measure the overall performance of our current algorithm for problem number 2. Yeah. So let's look at how do we do that? How do we factor in all the possible cases in a fair way, reasonable, fair way? All right, so remember our assumption. Yeah. So that P, right? Yeah, P, 1 minus P. So we start from there. Yeah. The average, we will do weighted average. Yeah. Because when we talk about average, there are many different meanings. Under different situations, there are many different meanings. And here, we use weighted average. So we need to consider weights for different cases. Yeah. So we will use two-step calculation. Yeah. Why 2 steps? Because we have some subcases, subcase averages to be considered. So we will calculate averages for subcases first. Then we combine those sub-averages to get overall average. So that idea. Yeah. So look at the first subcase. Yeah. So these matching cases and different matching cases. This is our first subcase. Yeah. All right. In this one, so you can see, because based on our first assumption, each one has the same probability. Yeah. So that we can assign 1 over n, 1/nth probability to each subcase. Reasonable. So it's fair, right? Yeah. So now you can see what is the average number of comparisons. Average number of comparisons. So we take this kind of average. Because the probability is the same, 1 over n, associated with the first, second, third, and the last. So everyone. So that's why we can do this. 1 plus 2 plus through n divided by n. Because the weights for all matching cases are the same. So we can do this. If the weights are different, we cannot do it in this way. Yeah. So the answer is 1/2 times parenthesis n plus 1. Yeah. The average for the first subcase. The average for the second subcase, because no match, there is only one subcase, one possibility. So that's the same thing. So that is n comparisons. Yeah. All right, so now we need to combine these 2 subcases to get the overall answer. So when we combine, we need to use our second assumption about probability, that P. Yeah. So the first subcase, based on our second assumption, the probability is P. Yeah. The complement part, no match case, 1 minus P. Now we do the weighted average. Now it is the time to do the weighted average. So what is the weight? Weight of the first subcase, that's the P. Weight of the second subcase, that's 1 minus P. Right? Combine, so we combine this way. Right? So the formula weighted average is this. Number of comparisons, the first one, multiply its weight. The number of comparison of the second subcase and multiply its weight. Then adding together, so we get the final answer. Yeah, so you can simplify it. Okay, so this expression, you can simplify it. Yeah, but when we do the simplification, remember n is the variable. Because n can change. n is the variable, right? P is a constant. Although here P is unknown, but we treat P as a constant. Okay, yeah, all right. After that, because in order to write the overall efficiency, there is a common way to do it. Yeah. Here, we look at the dominant term. Because in this expression, some term very small. So we can, most of the time, we can ignore those very small terms, but we only keep the most important term. So that term, dominates all the other terms. So we call it a dominant term. Yeah. And for this example, yeah, so that plus one, small number, so we can ignore, right? Yeah, so then we combine the coefficients for all the variable, all n part. Yeah, n is the variable part. So we combine the coefficients. One coefficient, 1 minus p, one coefficient, right? So 1 minus p, one coefficient. Another 1/2 times p. That's 1/2 times p. Adding together, so 1 minus 1/2 times p. Okay? Yeah. So our dominant term is this 1/2 times, 1 minus half p, 1/2 times p, parenthesis, whole thing. Yeah, that's the new coefficient times the variable n. That's the dominant term expression. Okay, all right. So we complete the analysis for this question. All right, so let me stop our second video here.